Hello and welcome to week 3 of Arduino Online. In this week, we'll be going over how to use the motor, buzzer, and ultrasonic sensor. So get excited and let's start off with the motor. The motor is a very simple device. All you need to do is create a voltage difference across the two ends and it spins. You can also make it spin faster or slower based on the amount of voltage you feed into it. Let's use the thermistor we learned from last episode to vary the voltage to test this out. As you can see, the more voltage we feed into the motor, the faster the motor spins, and the less voltage we feed into the motor, the slower it spins. You can see faster and slower. Okay, and that's it for the motor. Now let's move on to the buzzer. The buzzer uses one main method, the tone. The tone takes three parameters: the pin, which is the number of the pin you wish to set, the frequency of the tone you wish to play, and duration, which is the duration of the tone you wish to play. The Arduino editor comes with a default script containing the frequencies of all the notes that can be played on a piano. You can get there by clicking on examples, then clicking on digital, then clicking on any of these scripts containing the word tone. The notes and their respective frequencies will be stored in this header file called pitches.h. Now let's use these definitions to play a simple scale. As it is troublesome to type note all the time, I have shortened it to just n. You can do this with any replacement tool of your choosing. Now we have the tools we need to play a simple scale. Here in the melody array, we've defined all the notes from C4 up to D5. We've defined n to be 9, as the length of this array is 9, and so in the loop here, we know how many notes we need to play. Here in the setup, we've defined that 8 is the output. If you're using the Maker Uno, pin 8 is the output to the default buzzer on the board. In the loop here, we are looping through the entire array from 0 up to n, and playing the respective tone defined inside the melody for 200 milliseconds. This delay of 200 milliseconds here is to allow for the tone to play before moving on to the next part and looping back. Once the loop is done, we give it a 3-second break before repeating the scale. Great, right? As you can imagine, you can play all sorts of songs and tunes this way. I'll leave that up to you to explore on your own. Now let's talk about the ultrasonic sensor. The ultrasonic sensor has two parts, a transmitter and a receiver. The transmitter sends an ultrasonic pulse out. The pulse then bounces off some surface and is picked up by the receiver. Ultrasonic waves are just very high frequency sound waves. The term ultrasonic means that it is at least at a frequency that human ears cannot pick up, and therefore is not too noisy while you're using the ultrasonic sensor. Be careful about animals though, as some animals can pick up ultrasonic sounds, and this may be annoying to them. The sender is triggered when the trig pin is powered. After the receiver receives an input, a pulse is encoded into the echo pin to allow the value to be read. The value obtained from the ultrasonic sensor is the time taken in microseconds from when the pulse went out to when the pulse came back. Knowing the time isn't super useful though, so let's convert it to distance using the formula for speed. The formula for speed is distance over time, as the speed signifies how much distance is covered in a certain interval of time. We can rearrange this formula to obtain distance as being equivalent to speed multiplied by time. Now that we have the correct formula for distance, we need to find what value we should put in speed. The speed of sound is 343 meters per second in air. We can convert this to centimeters by multiplying this value by 100 as each meter it covered is worth 100 centimeters. Now we have 34300 centimeters per second. Now we're still not quite there yet. Now we need to convert the per second in terms of per microsecond. Each microsecond contains 0.000001 seconds. Therefore, at each microsecond, we would only travel 0.000001 times the distance of what we would travel in a second. Now we obtain the value we wanted, 0.0343 centimeters per second. Our final expression looks something like this. The divide by 2 is because of the distance being calculated is the distance to and from the object. To obtain just the distance between the sensor and the object, we need to divide this by 2. Now let's go over the code. In the setup here, we defined pin number 8 to be the output for the buzzer, as pin number 8 is also the pin designated for the built-in buzzer on the Maker Uno. We then set pin 11 to also be an output, as we are using pin 11 to trigger the ultrasonic sensor, and therefore we connect pin 11 to trig. We then declare A4 to be an input, as we are using A4 to receive the input from echo. We then start the serial interface using serial.begin 9600. Now let's define a method called ultrasonic, which returns the double containing the distance in centimeters obtained from the ultrasonic sensor. Defining methods helps to simplify your code and helps to abstract this part, and therefore when someone reads your code, they understand that you are using the ultrasonic sensor at this point. And they might not actually want to know how it works inside, as long as they know that it returns the distance. This block of code is used to send a short pulse into the trigger. It starts off with the trigger being low, it waits 2 microseconds, and it sets it to high. It then waits for 20 microseconds, and then sets it back to low. The receive duration will now be broadcast on the echo pin, and so we can receive this using pulse in on pin number A4. Let's store this value in time. Now we can use the expression we obtained earlier to calculate the distance in centimeters. You can also output the time to the serial interface if you wish to see that. Now, let's talk about the loop. The loop starts off with a short 200 millisecond delay. This delay is so that we don't spam the ultrasonic sensor, as spamming the ultrasonic sensor can cause it to overheat. This is also the reason that you should not power the ultrasonic sensor until you have connected all of the pins, as if you leave one of the pins hanging, especially the trigger pin, it can cause the trigger to be triggered at a really fast rate, and this can damage your ultrasonic sensor. This line obtains the distance reading from this method we defined above, and stores it in a variable called distance. If our distance is more than 2 meters away, we decide we don't want to buzz. The reason for that is that this model of the ultrasonic sensor does not detect very well any objects that are above 2 meters away, and therefore we don't want to be using these values as they are probably not very accurate. These 3 lines are used to trigger the buzzer. The reason that no tone is used is because this delay happens to be very short, and a short delay might cause some residual sound if you leave it, and therefore we should use the no tone method to stop the sound. As you can see, the no tone method is very simple. It just takes in one parameter, which is the pin you wish to stop. We then delay for the distance times 10 microseconds. As you can see, the closer the object is to the ultrasonic sensor, the shorter this delay, and the faster the buzzer will buzz. The further away it is, the slower it will buzz. A little bit like the parking buzzer that you may have heard in your car. We then print out the distance in centimeters. Okay, let's run the code. As you can see, the object is now 193.6 centimeters away, and we've detected it to be 192 centimeters away. This is close enough, but as you can see, unless you get a higher precision ultrasonic sensor, the ultrasonic sensor isn't too accurate. As we move closer, you can hear that the buzzer starts to buzz a little bit more frantically, and also the reading happens to get slightly closer to the actual value. And that is it for week 3 of Arduino Online. This week, we learned how to use the motor, play notes using the buzzer, and obtain distance readings using the ultrasonic sensor. In the next week, we will be going over some of the topics you might want to explore with your newfound fundamentals in Arduino. Hope to see you there!